4.5 billion years since its creation, planet Earth continues to inspire and delight with each new mystery that unravels. Today's episode takes us to Tornado Alley, a place in the United States that gets the most tornadoes in the world. With as many as 500 tornadoes each year, this is a goldmine of extraordinary natural phenomena. Eerie clouds loom. Supercells, which are giant tornado-producing thunderclouds, plunge the entire area into darkness. Scientists struggle to understand this hostile aspect of nature.
Right out over there.
Yeah?
Straight out over there.
Uh-huh.
Watch that thing hanging down right there.
Join us on a journey showing a glimpse of the amazing workings of nature. Tornado Alley is a large area touching 7 states in central United States. Here are endless miles of flatland. This is one of the few places in the world where you can see such vast plains. With no natural barriers, strong winds that blow from all directions collide. Instability in the atmosphere creates strong updrafts that in turn create giant cumulonimbus clouds, also known as thunderclouds. These particular clouds trigger rare phenomena. May is the season when storms are most likely to occur. The team heads to Tornado Alley to witness something that can only be seen there. This is Professor Howard Bluestein of the University of Oklahoma. He's a meteorologist who's been studying Tornado Alley for over 30 years.
I see towers up to the north. I see the boundary up here. Look at it. And it's coming towards us.
Uh-huh.
This special van, equipped with a weather radar, collects data from storms. Soon after leaving, the sky starts to get cloudy. The clouds gather, forming a dense cumulonimbus cloud.
Okay, our storm down here is starting to get a concavity on it. I think that will probably be our target storm.
Okay. You see the second cell here? You can see some side, maybe up there.
As a cumulonimbus cloud develops, it begins to rotate, becoming a supercell. A storm can sometimes generate hail the size of tennis balls. Professor Bluestein asks his students to begin their observations. They turn on the radar.
The base is good, and I'm looking at the contrast here on the side of the tower.
The supercell changes with every moment. It's almost like a living creature. The professor keeps track of every single change for his study of storms. The Erie supercell is now right above them.
Well, we're going to have to eventually go northeast. Any minute we're going to get a decent hailstone.
Chasing storms is dangerous. The professor's good judgment is key to collecting accurate data.
Okay, so we're going to have to go east, I guess, to protection, and then north and pick it up again.
Once the crew moves away from the supercell, strange clouds appear above them. Countless pouch-like masses fill the sky. They're rare clouds produced by complex currents within a supercell. Because they contain a lot of moisture, experts see them as an indicator of heavy rain. Sunset is more than an hour away, and yet it's completely dark. Thick clouds block the sunlight. By the time the team has arrived at the observation point, the supercell has grown even larger. Lightning flashes inside dark clouds. This is a phenomenon called intracloud discharge. Branch lightning produced by heavy collisions between currents is released inside the cloud.
Okay, we've got to go. We've got to move. All right.
Intracloud discharges are often followed by dangerously violent storms.
Maya, you're leaving! Leaving.
We were able to collect data, and the data that we collected will be interesting even without tornadoes. The storm came very close. It was a very powerful supercell.
Supercells generate all kinds of weather phenomena. Tornado Alley is known for frequently having these special clouds. In Tornado Alley, warm and moist air from the Gulf of Mexico meets cold and dry air from the Rocky Mountains. When two winds with big temperature differences collide head-on, the warm and moist air rises in a strong updraft, creating a cumulonimbus cloud. As the wind continues to upwell, the cloud eventually becomes a supercell. What's happening up in the sky? Let's find out by going aloft. A giant cumulonimbus cloud appears up ahead. Soon, a bunch of cumulonimbus clouds turn into supercells. The team decides to go near one of them. Low-hanging clouds can be seen off in the distance. In a few moments,
the pressure's dropping a lot. Well, as the pressure drops, the air gets more unstable. I don't like it.
the aircraft hits turbulence. It also starts to rain.
Lightning. Go sit down at Scribner Airport.
Flying in a storm is dangerous. They decide to land.
In this case, there's really nowhere to go. We let ourselves get surrounded by the weather, which is probably coming this way.
Supercells sometimes trigger storms, which rapidly grow and create an incredible amount of phenomena. In 2012, airborne photojournalist Amos Meyer was reporting from a helicopter. She witnessed a tornado that had wind speeds up to 60 meters per second. Large trucks flew around like tree leaves.
You could see a lot of debris in the air. I guess that were the homes and stuff breaking apart that it was flying over. All at once, they started flipping around, and I said, oh, that's tractor trailers. And so, you know, it picked up one and flipped it around, and picked up another one and flipped it around.
Tornadoes are a violent weather phenomena produced by supercells. Here is some rare footage capturing the moment a tornado hit. A dark cloud descends from the base of the supercell. When it hits the ground, it becomes a tornado. Every year, Tornado Alley gets hit by up to 500 tornadoes. Close to a quarter of the world's tornadoes happen here. Buildings get ripped from their foundations. Sometimes entire towns are destroyed. Some tornadoes can even be as broad as 4 kilometers and can move at an incredible velocity of 130 meters per second. That's twice the speed of a violent storm. tornado is a powerful force of nature that pushes the limits of human understanding. A tornado hit this town 10 days ago. Trees were broken like toothpicks. Vehicles and buildings lay in ruins. This frightening force of nature destroys everything in its path. This man amazingly survived the deadly weather.
Come on in. This. I want to show you. This is where the metal hit. A piece of metal come through that window and hit right there. And if anybody had been in here and it hit them, it would have killed them. Now, that's where we stayed, right in. We stayed right there in that bathtub. Anyway, we just got down in here like this. And my wife and I and our dogs. But this is all concrete all the way around this. So it's relatively safe. Not the safest place, but it's safe, you know.
The man and his family were forced to leave Tornado Alley and move to a safer place. One can never tell when or where a tornado will hit. Tornado Alley is a dangerous place to live.
It's telling you the tornado warning.
A tornado warning urges people to take shelter. Tornado warnings are issued here at the National Weather Service.
You're looking at the radar imagery.
Special forecasters analyze weather data on a round-the-clock basis to detect signs of possible tornadoes.
Part of the National Weather Service radar network, and they have
精度、当たる確率何%ぐらい当たるんですか?
It's not perfect. Very far from perfect. So what we call the false alarm rate or ratio, 7 out of 10 tornado warnings don't have tornadoes.
The accuracy ratio of a warning is 30%. That's the best it can get, even with the latest technology.
We don't understand all of the details in the atmosphere that come together to produce a tornado event, and we don't have models that actually know much at all about the full...
The mechanism behind how tornadoes form is still very much a mystery. Forecasters focus on a hook-shaped cloud called a hook echo that appears on the weather radar. Evidence of hook echoes increases the possibility of tornadoes. Meteorologists are constantly trying to figure out how to increase the accuracy of warnings in order to prevent damage caused by tornadoes. A key person forecasters depend upon is Professor Bluestein. He collects weather data in Tornado Alley. He studies the mechanisms of tornadoes.
We hope that if we're able to understand better why some storms produce tornadoes and others don't, then maybe we can improve our ability to issue warnings and do forecasts to the public. If we can increase the accuracy of forecasts, then that means that people will be more likely to heed a warning and seek shelter.
Tornadoes often occur on hot days when cumulonimbus clouds grow substantially. It's 35 degrees Celsius, the ideal temperature for collecting data.
Oh, it looks really intense. Oh my God. It's got hail in it. It's a very intense storm now.
Really?
Yeah.
An enormous cloud is visible in the distance. It's a cumulonimbus cloud that turned into a supercell. The sky is getting darker. The cloud, which easily exceeds 50 kilometers in diameter, covers the entire area. It's a giant supercell typically seen in Tornado Alley. The supercell swallows surrounding clouds and grows even larger. As the van approaches the center of the supercell, the team witnesses a strange phenomenon. Dust is swirling under the supercell. Will there be a tornado?
We saw sand swirling around?
Yes. Yeah, it could have been a gustnado, maybe.
A gustnado is a twirling wind caused by a strong updraft. It's a phenomenon commonly seen with powerful supercells.
So what do you think, Zach?
It's starting to look a little bit better. I noticed that, especially on the radar, we started to see some sort of hook-like feature at the upper levels, and we're kind of getting we have a decent base here, and maybe he's starting to mature a little bit better.
The team moves further toward the center.
It's really neat there. That little hook-like feature, and you can start to see the turquoise color.
Yeah.
Kind of the aqua color behind it. That's really neat. That means we probably are starting to get some pretty big hail in there. Once we start to get the bigger hail, we would start to expect these more aqua colors in here. kind of like a greenish tint to the storm.
Part of the supercell has a bluish tint. This means the cloud contains an excessive amount of water.
Look at that.
Is that starting to...
Look at that hail.
Okay.
Is that hail?
Yeah, I think so.
Suddenly, large hailstones start to fall.
There's a little bit of rotation here.
Yeah.
I'm a little bit concerned about our location right now.
Yeah, I think you need... I was coming...
So we're going to have to move south.
Yeah, I was going to tell you to come look at the radar.
Let me take a look.
Shifting a little bit.
After checking the radar, the supercell suddenly began to lose intensity.
Okay, we just had the gust front. This thing is gusting out.
Supercells grow quickly, but they weaken just as quickly. These sudden fluctuations make it that much more difficult to understand the mechanisms of tornadoes.
Right now, we are not where we want to go. We've made progress, but we haven't fulfilled our ultimate goal yet. And the reason is, you don't learn everything there is to learn about why tornadoes form from observing one particular storm, or even two particular storms. It's a mystery because we're trying to understand why they form. So it's a real challenge.
On their way back, the team gets a surprise. On the edge of the supercell,
Double rainbow.
a rainbow has formed. The powerful supercell offers a glimpse of nature's mystical beauty.
It's amazing to see.
Beautiful rainbow and storm. Look at that. That's incredible. Very pretty.
Tornado Alley is a place where winds collide, allowing us to witness the immense and sometimes unpredictable power of nature.